4x minus 3.
Mm-hmm.
And then that would be 3x cubed plus 2x squared minus 3x plus c.
Mm-hmm.
Um, and then would I then need to sub in minus 1 into the x's?
Yeah.
Or even would I need to do 0 equals to I'm going to put this in my calculator, can't I? And just put c as x.
Yep.
And then, so, yeah. And it says that c is minus 2.
And so, what is the f of x equal to?
3x cubed plus 2x squared minus 3x minus 2.
Minus 2. 3x cubed plus 2x squared minus 2x minus 2. Any questions there?
No.
Oh, 5 marker. Good, good, good. I just want to see. It's a bit weird. Oh, that's fine. Let's just try the second one. See how we do with that.
Okay, so I first of all need to make it so that the over x squared thing is gone.
Right.
But I will wait. Would that just be 5 root x minus 3x to 3 over 2 times x to the minus 2?
Yeah.
And then I can just do 5x to the half minus 3x to 3 over 2.
Mm-hmm.
And then that would be equals to 5x minus 1.5
Mm-hmm.
and minus 3x minus a half.
Mm-hmm.
And then I need to integrate that.
Mm-hmm.
And so that would be so 5 divided by minus so minus 10x to the minus half minus 6x to the half plus c.
That's it. And then you just sub in that and solve for c. So minus 10 x to the minus a half, minus 6x to the half, and then you just find the c. Grant. You're good for that. Just want to see if these are. Oh, that one looks weird. I'm going to grade into a curve. That's the same thing. Just want to see this one up here. Find y in terms of x, simplifying the coefficient. That's fine. Oh, they're just. It's really just the same thing. This one, everyone makes a mistake with it. Let's see how you do with this one.
Okay. Would I first need to integrate the thing?
Yep.
So would that be so? First of all, to make it so that it's like normal, would I do 3/2x² minus a quarter x to the half? Or no, or to the minus half, sorry.
Andrey, that's brilliant. You'll be fine for the rest of that. Yes. So most people say that's 4x to the minus a half, but actually because of Bidmus, that's a quarter. The power is connected only to the x. Grand. Great. Finding functions.
Yeah, I think a tick.
It's a super tick right there. Definite integrals. This is when you actually sub in numbers. Let's see how we do. How do you do here?
Mm. Um, would I need to expand out the x to the third minus 1² thing?
I think so.
And then so that would be x to will that be x to the x to the ninth?
How do you multiply index numbers?
Oh, you add them together.
Mm-hmm.
So would that be 2/3?
Mm-hmm.
So x 2/3 minus 2x to the third
Mm-hmm.
plus 1. And then do I need to integrate that or?
Mm-hmm.
And so that would be so 1 divided by 5/3,
Mm-hmm.
which is so 3/5
Mm-hmm.
x to the 5/3. Um, and then minus 3/2 x to the 4/3 plus x plus c.
Mm-hmm. And for definite integration, c is always going to be 0.
Okay. I don't need to put it in basically.
Yeah.
Okay.
So what is this 1 and 0 about? Do you know?
No.
So you may not have seen this before. I just took a guess that you did. You sub 1 for x, and then you take away what you get when you sub 0 for x. So 3/5 times 1 to the 5/3. So wherever there's an x, sub in 1. And so that whole thing, take away what you get when you sub in 0.
Oh, right.
tell me what. Let's see if that one. Let's see. So 3/5 times 1 to the 5/3.
Which would be
Or are you just putting the whole thing
0.4.
in? Yeah, 3/5.
Yeah.
So that one's 3/5. This is 3/2 plus 1. And then 3/5 times 0.
0.
3/2 times 0.
0.
And 0. So, what is your final answer?
My final answer would be 10th.
A 10th, is it?
Yeah.
Did we go wrong somewhere? Let's see. My calculator. Oh, x to the 3rd minus 1. That's what I should have done. 1/10. There we go. So this one is definite integration. So it is the area between 1 and 0. So we haven't gotten to that yet. But if it's between 1 and 0, so you sub in 1, and then you take away what you get when you sub in 0.
Yeah.
And other than that, all the integration is the same. Any questions there?
No.
Okay. Oh, this looks good. Okay, how about this?
Okay. So do I just need to do the same thing again, where I sort of expand out the thing?
Nothing to expand.
So would I just put the 5? Would I just do what we just did then, and sub in the 5 into the x, and then put the 1 into the x minus the 1 into the x after?
Mm-hmm.
Oh right, yeah, and then so do 2p times 5.
No. Integrate first.
All right, so 2px. So would that be px squared plus 7x and now do the thing.
Mm-hmm.
So do p5 squared plus 7 times 5 minus p1 squared plus 7 times 1, and then that would be equals to 25p plus 35 minus p minus 7, and then that would give 24p plus 28. And then would I do 24p plus 28 equals to 4p squared? And then just do 0 equals to 4p squared minus 24p minus 28. And so that would be p is 7 or p is minus 1.
P equals 7 or p equals minus 1. And p alpha. I don't think this will work. No, it won't work. They took steps to make sure. Minus 1 or 7. Any questions there? That's very good. Let's say 2 exam questions. Is the top one worth doing, or you think you'd be okay with it? Yeah, you did great with that one. I think you'll be fine with those. It's kind of interesting. Yeah, let's try the bottom one.
So what I do? So first of all, integrate 9 root x, which would be 6x to the 1.5. And then with that, I then need to do so brackets 6 and then bracket k to the 1.5 minus 6 times 4 to the 1.5, which would equals to 6k to the 1.5 minus 48 equals to 702. And then 6k to the 1.5 is equals to 750. And then can I just put that into my calculator? And then that would be says that k is 25.
And I got the same thing by putting the very original thing in. And so we can be pretty sure k is 25. Any questions there? That's good. Let's see this one. That's very similar. This one show that find the integral. That's all right. Similar. I think you'll be okay with it. Okay, definite integrals. What do you give yourself?
I think probably a 2.
It's good. Okay, area under curve. So this is what we're talking about. So you can prove that integrating the equation of a function between two x limits gives you the area. So if you were to, so if this function, y equals the f of x, so this is some function, x cubed, x squared stuff, and if you integrate that function between b and a, so you sub in the b and then you get whatever you get minus the a, and then that gives you that area. Okay, how about this one?
Sorry, what's this topic called? Sorry.
This is area under curves. So this is, it's like applying integration.
Okay. So would I need to? But I literally put that into my graphical calculator.
Well, I don't know if it has that function. Okay, so this is what it looks like. Shift zoom, I don't know, auto. Okay, so there it is. And so, hang on, view. So they're saying they want this area between the curve and the x-axis. So this area down here. So how would you get that?
Sorry, which area do they want?
They want the area between the curve and the x-axis. So this area in here.
Right. Could you make that into like 2 right angle triangles or?
Integrate.
Okay. I just need to integrate that.
Mm-hmm.
So 20x minus a half x squared minus a third x cubed.
So we want an area. Where does this curve start? Where does it stop?
Curve starts at -5 and ends at 4.
And so it is between 4 and -5.
And so does that mean I need to do? Oh, right. And then just do the substitution thing again.
Mm-hmm.
So 20 times 4 minus a half times 4 squared minus a third times 4 cubed minus 20 times minus 5 minus a half minus 5 squared minus a third times minus 5 cubed. And then that would be equals to... Can't do the integration thing, yeah.
Yeah. And so at that point, I kind of just want to make sure I get it right. So you can use graphical, you can use whichever. Between -5 and 4. So tell me what you get for that one.
I got 121.5.
Shift solve. Come on, calculator. Ooh, 121.5 units squared because it's area. That's what it looks like. Yeah. Wow, calculator's still thinking. This one. So what made this a bit easier was putting it into the graphical calculator, and we could see it was 4 and -5.
Yeah.
Usually you'd have to solve the quadratic first.
Yeah.
And it would say x equals 4 or x equals -5, and then you integrate it there. However, I think that we did our work. We didn't actually have to show all this stuff. Once you get 4 and -5, just integrate between 4 and -5. That just goes into the calculator straight away. I just want to see, is there some way? What other thing can you do? Graphical solve. Yeah, shift graphical solve or something. Xcal? Oh no. No. Just wondering if there is a possibility to get the area just from GT. Oh, I don't know. No, doesn't look like you can. There probably is though. There always is. Any questions about that one?
No.
Okay, I'm pretty sure there's a way to get that area. Anyway. Okay, how about this?
So okay. Okay. So um hmm. Not really. Oh, this will be the where I have to find the roots, isn't it?
Mm-hmm.
So, do I even need to integrate this?
That's part B.
So if I literally just put that thing into my graphical calculator, it'll give me the roots, won't it?
Yep. Or you can use the solver for the quadratic solver, whichever you prefer.
And then the roots is -2 and 6.
-2 and 6. And so what are the coordinates of A and B?
So A is equals to -2, 0.
Yeah.
And B is equals to 6, 0.
Well done. Part B.
And then here I need to actually like integrate the thing, don't I?
Mm-hmm.
Or even could I just put into the integration thing? Yeah, could I put 6 and then -2 and 12 plus 4x minus x squared and give us the answer?
Yeah, go on, try that.
And then that would be equal to I got 256 over 3.
Great. Any questions there?
No.
This is good. This is very good. Okay, how about this?
So I'm just writing this down quickly.
It's all right.
Okay. So would I? Yeah, would I just put that minus x minus 1 squared x minus 4 thing into my calculator, like the graphical thing?
Yeah, give it a go.
And then that would be and then the roots would be so 1, 0, and q is equals to 4, 0.
Mm-hmm.
And so would I then put that into the integration thing?
Mm-hmm.
And so it would be 4 and 1. And then will I just put that into minus x minus 1 squared x minus 4?
Yeah, so try that, because it's just a bit complicated.
Okay. And so I've got 27 over 4.
4. 27 over 4. Great. Any questions there?
No.
It's very, very good. Let's see. Same thing. It'll be fine, I believe. Yeah. Yeah, this is a bit more like it. Okay. How about this?
Okay. So. Okay. So. There's no roots here. Will I work out what 6x squared minus 12x plus 9 is? Or no?
Yeah.
So sorry, do I have to integrate, or do I have to put into that polynomial thing?
It doesn't look like it has any roots.
Yeah.
So how do you usually find the yellow area, shaded area?
We would get the roots and then we'd put it into the integration thing.
Yeah, so integrate. We don't have the roots.
So do I need to integrate 6x squared minus 12x plus 9?
Yeah.
And so that would be equals to 2x cubed minus 6x squared plus 9x. And I don't need to put the c, do I?
No. It's the area.
And um, oh, so because there's no roots, would I just put 0, 0 or no?
What is this? What is it between? What is the area between?
0 and k.
So let's say k and 0.
Okay. And then, so that would be 2k cubed minus 6k squared plus 9k minus 2 times 0 cubed minus 6 0 squared plus 9 0. And so overall that would come out as 2k squared minus 6k squared.
First one's cubed.
Sorry, cubed minus 6k squared plus 9k. It says equals to 27.
Mm-hmm.
Oh, and then it'll be 2k cubed minus 6k squared plus 9k minus 27 equals to 0.
Mm-hmm.
And then I just put that into my calculator.
Mm-hmm.
And so k is 3, I think.
K equals 3. K equals 3. And so basically we have to integrate 6x squared minus 12x plus 9 between k and 0 and get an area of 27.
Yeah.
And so let me just go to my simple one. 6x squared minus 12x, I think it was plus 9. Yeah. That's between 0 and they're calling it k. Let's call it x. And that is equal to 27.
Yeah.
Hopefully it gives me an answer. Might not. There we go. 3. Same thing. Okay. Any questions there?
No.
Okay. Let me see this one. That's easy peasy. Yep. That's fine. Same thing. Great. Okay. Areas under curves.
Probably a tick.
Let's see. Area under the x-axis. Yes. Before we do anything. Okay, so you have 2 rectangles. That's up at 4. That's down at minus 4. This x is at 5. What is the area of the top rectangle?
Will it be 4 times 2.5?
The height of the top one is 4.
Yeah.
And the width is 5.
Oh, sorry. So just 20.
What is the area of the bottom rectangle?
It'll be 20 as well, won't it?
Yeah. If you ask your calculator what the area of the bottom one is, your calculator will say it's minus 20. because it will do 5 times minus 4. And so just watch out for that. So if you are integrating a curve and they say find this area, like what we've just been doing, and it's under the x-axis, calculator will say that's minus. It's actually plus.
Yeah.
Let's try this one. Example 10.
So we're going to expand the brackets first.
Yep.
So that would be y is equals to x squared minus 3x.
Mm-hmm.
And do I need to then integrate that?
Yep.
And so that would be a third x cubed minus 3 over 2x squared.
Mm-hmm.
And then would I put x squared minus 3x into my graphical calculator?
Yep.
And so the roots would be 0 and 3.
Mm-hmm.
And so can I just put that thing into my calculator then?
Yep.
That would be minus 9 over 2.
And so is that area minus 9 over 2?
Oh no, it won't be. It'll be 9 over 2.
Why is that?
It was minus 9 over 2, but the area will be 9 over 2, won't it?
Why is that?
Because shapes can't be had minus areas.
That's it. And so it says it's minus 9 over 2, but we know that it's going to actually be positive 9 over 2, 4.5. So that's what it looks like. Yeah, it's because it's below the x-axis. It's below the x-axis, so it's saying it's negative. So the area is 4.5, positive 9 over 2. Any questions there?
No.
And so, yeah, you can see it's between 3 and 0. Integrate that. Yes. Okay, how about this one?
So okay, so would I actually put that thing into my graphical calculator and then get the roots?
You could.
And so the roots are minus 3 and 0.
one more
and
route.
pardon.
There's one more route.
All right, 0 and -1.
Mm-hmm.
Oh, so -3, 0 and 1.
Mm-hmm.
So what would I do then?
You tell me. So we have it, and it looks something like that.
Yeah.
And so they want the area. How do you do that?
So would I do it step by step? Would I get the first area and then get the second area?
Yes.
So would I first do 0 and -3 integrated with that, and then do 1 and 0 integrated?
Yep.
And so that would be so. The first one is 45/4.
That's between 0 and -3, is it?
Yeah.
Okay.
And then after, it's going to be 1 and 0.
Mm-hmm.
So and then that'll be -7 over 12, but it'll be +7 over 12.
Yeah.
And so that will be equals to 71/6.
71/6. 71/6. So what if you just put into your calculator between 1 and -3 and didn't do the two separately?
I would have got 71/6. Oh no, I would have got 32/3.
So I don't know exactly what it would be, but basically it would you would be subtracting this area from this one, and that's why you'd get the wrong answer. So you would have, instead of having like the left area plus the right area to get the total area, it would be the left area minus this one, because it would be adding on a negative.
Right. Okay.
And so yeah, you got a first shot. That's why you do the two separately. Any questions there?
No.
Let's see. That's very similar. That's even easier. Even easier. That one's similar. Similar. Let's just do the hardest one. Yeah. How about this one?
Okay. So for A, I just need to put sub 2 into the equation and it'll be equals to 0.
Yep.
Right, yeah. And then for B, this is factorise. Does that? Oh, so I can just put that into my calculator, can't I?
Mm-hmm.
And so that would be so x plus 6. So this is all in brackets. So x plus 6, and then x minus 2, and then x plus 2.
So something's not right. What is 6? So that gives minus 24. But we wanted... Oh, no, it is right. Sorry. I was looking at something else. Yep. And part C.
So put that into my calculator.
Right.
And then so the roots are minus 6, 2, and minus 6, minus 2, and 2. And then would I just do the integrated thing again, and then just do the equation, and then with the integrated, so minus 6 and minus 2, and then do the second bit with minus 2 and 2.
Yeah. So that's y with respect to x, and then plus the integral of the other one, or just, you know, the absolute thing. So make them both plus. I just figured it out, I think. Menu, graph, x cubed plus 6 x squared minus 4x minus 24, and we want to draw that, and so we do. Let me just zoom to shift view window standard, draw. Oh, it's even worse. Shift zoom auto. No, shift zoom, shift view window. Why? Initial? No, let's go standard. So this one, you do shift graphical solve, press right, and you see the integral one?
Yeah.
And then you can do that one. And I used mixed. And so mixed, you go to one root, press execute, and then press right down to the other root, execute, and it shades it in for you.
Yeah.
And it says it's 128. And this one is, oh, I don't have the answer for C, but yeah, you'd get 128 if you did it.
Yeah.
Area under the x-axis.
Yeah, I think it's sick, honestly.
You killed it. You killed it, man. So what's left? Area between those. Okay, so that's a real difficult thing at the end. But you did great. How was that for you, Andrey?
Yeah, I was good, thank you.
And so, do you want to finish this and then move on to something else next time?
Yeah, probably just finish this, yeah.
Okay. And any idea what you want to do after, or just the next topic?
Yeah, just whatever the next topic is, probably.
Okay. Any questions for me in general?
Are you able to do an earlier time than 7?